Okay, hello class. Ito yung isang meeting na recording na hindi ko pa nabibigay. So ito. Ito ay examples lang dun sa part ng geometric optics. Okay, so maganda lang i-discuss na hiwalay kasi maganda yung mga topics, subtopics na meron dito. Okay, first things, ito ay mag-focus tayo sa mga camera, sa eyes, telescope, magnifier. Okay? Okay. So, ito, cameras. First things first, ito yung cameras natin, may mga lens sa loob. So, tinatawag natin sa kanila ay elements of lens dahil ito ay system ng maraming lenses. Okay? Okay, so pag bumili ka ng camera, bumili ka ng lens, tinignan mo yung lens niya. Sa description ng lens, marami siyang sinasabing 7 elements na lenses, ganun. Okay, so dinidetalye nila yun dun. Okay? And then sa mga lenses na yun, gumagalaw-galaw sila so that you can adjust the focus and yung distance na nakikita mo. Okay? Sa sensor mo or sa picture mo in essence. Okay, so sa mga lenses, meron tayong mga focal length, okay? Focal length na tinatawag or yung F. Okay. So ibig sabihin lang na a higher focal length means that yung camera mo or yung lens mo, mas makakakita siya ng malayo. Okay? And then, kapag mababa yung focal length, mas wide yung makikita mo. Okay, so guide yun sa pagbili mo ng lens sa camera mo. So if you're using your cameras to focus on people far away, okay, kuwari sa concerts, ganyan, or even mga small things like birds and etc., you may want to use a large focal length for your lens. Okay, and then if you're just taking pictures of landscapes, ganyan, it would be nice to have a low focal length. Okay. So, tapos sa lens natin, meron tayong tinatawag na F number. Okay, so yung F number, ito yung ano niya, tawag dito, defined siya as this, focal length divided by the aperture of the lens. Okay, aperture of the lens. So meron dito yung aperture. Ito yung nagko-control kung gaano karaming light yung papasok. Okay? So, ayan, F over D siya. And then, meron tayong tinatawag na f-stop. Okay? So, yung f-stop, ito yung f-stops, ito yung numbers by which nagbabago by 1 over square root of 2 yung F number. Okay? F number. Okay, so ito ay mga f-stops. So if you're gonna multiply F over 2 by as 1 over square root of 2, ang lalabas sa kanya ay F over 2.8. Okay? And so on. Okay, so ito yung mga usual f-stops. Tapos range siya. Okay. And then, kung gusto mo basahin siya in terms of F number, ito ay F2, F2.8, F4, F5.6, F8, F11, F16, or kung gusto mong basahin na in other way, pwede ito maging aperture of F over 2, F over 2.8, and so on. Okay, so let's try an example para di tayo magulo. Okay, meron tayong kunyari tinatawag na telephoto lens. Ibig sabihin, yung telephoto lens ay malaki yung focal length niya. Okay? Parang telescope. Yeah, telephoto lens siya. So, for a 35mm film camera, so yung 35mm film camera, ito ay standard. I mean, may certain na dimensions itong 35mm film camera. And then, ayun, yung focal length ng lens mo ay 200mm. So, ibig sabihin, napakalaki ng zoom niya. Makikita mo dito, 135 pa lang to. Tapos, meron daw siyang f-stop na ranging from f2.8 tsaka 22. And tinatanong sa atin, what would be the corresponding range of aperture diameters? And then, what would be the corresponding range of image intensities on the film? So, una, madali lang una. Yung una, kaya natin to ma-solve. So, this is, yung D would be just F over F number. Okay. So, ayun. Yung F natin would be the focal length of the lens. Tapos, F number is yung binigay sa ating number, which is 2.8, 22. Okay? So, ayan. Pansinin mo na for F 2.8, nakabukas yung diameter mo. So, nakabukas yung aperture. No? Nakabukas yung aperture ng lens mo. So, marami pumapasok na light. And then dito, maliit yung butas. So, 9.1 lang. Mas madilim yung makikita mo. So, ito yung range niya. So, 9.1mm to 71mm yung laki ng diameter ng aperture natin. And then, tinatanong sa atin corresponding range of image intensities on the film. So, image intensity can be obtained by kukunin mo lang yung ratios ng square ng diameter or ng frequency. So, paano yung relationship nila? Yung intensity, proportional siya sa d squared over f squared. So, kung in this case, kung gusto mo ng, syempre kailangan mas malaking number, no? Para makuha yung mas malaking value ng quote-unquote range. Okay? So, to do this, ito ay 71 divided by 9.1. So, divide mo lang sila, then square. However, kung gusto mo gamitin yung F number, yung reciprocal yung kailangan mong gamitin. Okay? So, una, 1 over 2.8 divided by 1 over 22. So, ito yung lalabas. And same lang din ang makukuha mo. So, that's 62. Okay? So, you can get up to 62 times yung pinaka-smallest na aperture versus dun sa largest aperture. Okay? Okay. Right. So another topic na maganda dito is yung eyes. So syempre meron din tayong literal na lens sa eyes. Okay, so may lens tayo dito. And we use it to form images. No? So ito yung mga real world object natin. Pag nag-pass through yung light rays coming from that object towards our eyes, ibabato siya doon sa likod sa retina natin. Okay? Nalalagay yung image doon. Okay? So once that image forms in our retina, magre-register yun sa brain mo. Tapos babalik rin niya na lang ulit para makita mo tong object nito. Okay. So kapag nalalasing tayo, nahihilo tayo, na nai-impair yung ability natin to do that. Okay. To do that tawag dito, flipping of an image. So kaya nahihilo tayo. Tawag dito, nag-iiba yung orientation ng mga objects sa paningin natin. Okay, so meron tayong mga defects ng vision and we want to correct them. So meron tayong nearsightedness or myopic eyes, tapos farsightedness, which is yung hyperopic eyes. So ano ba nangyayari? Minsan, sa nearsighted eye, yung mata mo masyadong oval. Okay, masyadong oval. Ang nangyayari, so pagpasok ng light rays, nagpo-form yung image sa harap ng retina. Okay. So, hindi siya umaabot sa actual retina. Yung aabot sa retina mo ay somewhat blurred. Okay. Ganon din nangyayari sa farsighted eyes. Maaikli yung eyes mo. Or yung cornea, not curved enough. Okay, so, mayroon either sa shape ng eyes mo or dito sa mismo lens part, dun may problema. So, sa farsightedness naman, nagpo-focus siya sa likod ng retina. So, malabo yung makikita mo. Similarly. Diba? Okay. So, gusto natin, lagyan natin ng lens para makorek yung mga bagay-bagay. Okay. So, suppose meron tayong isang hyperopic eye. So, near sa farsighted eye. Meron tayo dito, farsighted eye. And gusto natin na makita yung object na ito clearly. So, ito yung object, nearby object. Ang mangyayari, as usual, magpo-focus sa likod. So, hindi niya makikita ito ng malinaw. Ang gusto mo maging focus siya dito. Okay, so magde-design ka ngayon ng lens mo in such a way that itong lens na to magkakaroon siya ng dito. Ililipat niya yung focus ng bagay mula dito papunta dito. Okay? And then, kaakibat nito, ilalayo niya yung focus sa malayo. Parang ilalagay niya yung object dun sa malayo. Para yung light rays niya, it would seem that it would flow or focus in this area kung nasaan yung retina mo. Okay, so ayun yung niya. Ayun yung sense nung paglalagay ng salamin para makorek yung vision. Okay, so let's try. Feeling ko mas madali pag tinry natin. Okay, so meron tayong mga terms dito. So the near point of a certain hyperopic eye is 100 centimeters in front of the eye. So ibig sabihin lang nun, yung near point ay yun yung point kung saan ka magkakaroon ng clear vision kapag meron kang farsighted eye. Okay? So ito yung nearest point na makakakita clearly. So, pinatanong sa atin, find the focal length and power of the contact lens that will permit the wearer to see clearly sa distance na 25 cm in front of the eye. Okay? So, gusto mo, meron kang object 25 centimeters and ang mangyayari, ililipat mo yung image nito somewhere doon sa near point. Okay? Okay. So, to do that, para mangyari yun, gagawin mo lang itong formula natin for the image distance and object distance. So, yung object mo dito would be the object, 25 cm. Tapos, ililipat mo ngayon yung image mo dito. Okay, so, ayan ay negative 100 kasi nasa kaliwa yung image. Tapos, nandito sa right side yung light ray. Okay, by convention, negative mo siya. Mahanap mo ngayon yung frequency which is plus 33 centimeters, and if we are finding optical power, kunin mo yung reciprocal ng F. Okay? So that's 1 over 0.33 meters. Convert lang. And then, yung units niya would be diopters. Okay, so ito yung usual na ginagamit ng mga optometrist para ma-measure yung gano'n ka-powerful yung lens mo. Okay, so that's what you do to correct hyperopic eyes. And then next, try naman natin sa myopic eye. So yung myopic eye naman, far point naman ang meron siya. Ito yung farthest point kung saan ka makakakita clearly. Okay? Kasi nearsighted ka nga, di ba? So pag malayo na yung object, hindi mo na siya makikita na maayos. So yung far point, this dictates kung nasaan yung clearest na farthest distance na clear yung kanina. So that's 50 cm daw sa a certain myopic eye. Okay, and then we are trying to find the focal length of power and power of the eyeglass lens para makita siya ng object at infinity. May assumption tayo na 2 cm in front of the eye yung lens. Okay, so pag ganun, ang mangyayari lang is yung image na gagawin ng lens mo is decreased. Okay? Decreased. Kasi 50 cm in front of the eye, pero meron kang eyeglass lens that is front 2 centimeters front of the eye. So, babawas mo lang yon and you have this. So, yung image mo magpo-form dapat dito kung nasaan yung near point ng mata. Then, yung object daw nasa infinity. Then, okay. So, you use that. Okay. So, you want this to happen. Okay? Okay. So, ayan. Ayun lang. Ganun lang din gagawin mo. So, 1 over infinity for the object. And then, 48 kasi 50 minus 2, tas negative kasi yung light ray nandito pero yung image na sa kabila. And as usual, you get your diopters. Okay, lipat mo muna sa tamang unit. So 1 over negative 0.48 meters, you have this negative 2.1 optical power. Okay, nice. Okay. Next naman is a magnifier. Kunyari meron tayong gustong i-magnify ng object. Okay, so kapag tinignan mo yung object at your, say, kung saan malinaw yung mata mo, for this case, 25 centimeters malinaw, ayan, makikita mo clearly itong worm dito. However, if you want to go near, para mag-zoom in sa mata mo yung tinitignan mo maliit, hindi na siya magpo-focus sometimes, and then you need your magnifying glass. Ayan. So, kapag meron kang magnifier, yung worm pwede mo ilagay sa mas malapit sa near point ng mata mo. Okay, and then yung image nun would be shifted to become larger. Yan. So, huwag na natin i-divulge yung details dito. Ang gusto lang naman natin dito is meron tayong tinatawag na angular magnification, which is yung theta prime divided by theta. Okay, so theta prime would be the angle sa optical axis mo kung saan nandun yung line going towards your eyes. Okay, gamit yung parallel rays, i-trace back mo siya. Ito siya. Yun yung angle na yun. And then yung theta would be, for this case, mangyayari dito yung theta mo is actually makukuha mo siya as y over 25 centimeters. Okay? Okay. So yung theta prime, so that's okay, compare lang natin yung magnification is the previous then the new one. Okay, sa previous, meron tayong ganito. I-assume lang natin yung theta is small para tangent theta is just equal to sine theta. And then, magamit lang natin yung y over s. And for this case, theta is y over 25 centimeter. Tapos dito naman, ganun din. Mangyayari lang is that nakadepende ngayon sa focal length nung lens mo. So, theta prime is now y over f. And if we're gonna combine that in here, theta prime over theta, ayan na. Y over f divided by y over 25. Okay? And that, yung 25 is an approximation, no? Kung bakit siya 25. Siya lang yung usual na near point ng mata. So you have this kind of a simple equation for your magnifier. So, syempre, hindi ka pwede mag-focal length na 0, no? Syempre, didikit mo na yung mata mo doon para mangyari yun. Pero yun, ito yung equation for the magnifier. So, the smaller the focal length of the lens, lalong lumalaki yung makikita mo object. So, similarly, sa microscopes, ganun lang din yung mangyayari. Mangyayari lang dito, dalawa lang yung magnifier mo. So, double magnifier lang siya. So, you have this setup. Meron kang mata, tapos ito yung microscope mo. We have your lens 2, lens 1, or objective. Diba? Objective yung tawag sa microscopes. And then, from here, yung M1 natin dito would be S prime over S. Okay, and then kung gusto mo powerful yung objective mo, yung S1 usually maliit siya. So S1 almost equal to F1 na siya. S1 prime, negative pala ito, no? Over F1. Okay, so with this, tapos yung pangalawa mo, yung eyepiece mo, gagamitin na lang yung sa magnifier assumption na this is just 25 over f2. 25 cm. So usual near point na mata over f2. Okay, and then the combined one, multiply mo lang itong dalawa. So we have this. Neglect lang yung negative sign dahil ito ay magnification naman. So negative magnification, flip lang siya ibig sabihin. Pero ayan, hindi na siya ini-include ba? Kasi gusto mo lang naman makita kung gaano kalaki yung resulting object for your microscopes. And then lastly, similarly, for telescopes, ganun lang din for telescope, theta prime over theta, but this time, hindi disregard mo na yung 25 centimeter na assumption, and then you're left with this. Okay? Dahil dito, yung image mo, halos yung image mo, di ba kanina ito ay y lang. So yung actual object mo nasa infinity na rin. So nasa parang same lang siya dun sa kung nasan yung image. Okay? So that cancels out, and yung for telescope, nagre-rely siya sa focal lengths ng dalawang lens. So negative f1 over f2. Okay, so yan siya. So ratio lang nun would be your magnification for your telescopes. Then as usual, try nyo lang yung mga example sa libro para may masagot kayo sa exam. Okay. Ayan. Good luck, guys.